All right, our learning targets for today. We're in 3.1.2. Today is the 3rd of November. And our two key learning targets have to do with similarity and proportions. Today, when you leave here, I want you to be able to define and recognize similarity. Similarity is our big key word for today. So I want you to be able to tell me what similarity is, and then also how does it compare and contrast with congruence. We've talked a lot about congruence, not much about similarity so far. The other thing that we're going to start working on today, and you're going to see if you look down through the learning targets for the next couple lessons, solving proportion keeps coming up over and over and over again. We're going to introduce proportions today. I want you to be familiar with what they look like and kind of the rules of how to build proportions, but I don't expect you to be experts at solving proportions today, just being able mainly to write proportion, maybe not solve today. To remind you what a proportion looks like, it is an equation that has a fraction on both sides, and that's it. Has a single fraction on both sides. So you're going to have something over something on one side and something over something on the other side. Do you guys remember the Algebra 1 strategy that you've learned, actually probably back to middle school? You guys remember how we solve these things? Cross multiply, yeah. Multiply across the equal sign. It kind of looks like an X. Some people call it the butterfly method because it kind of looks like butterfly wings. Yep. So we'll practice a little bit with that today. We're only going to do one problem where we actually solve it with cross multiplication, but we will solve a bunch more later on in the unit as well. Our big topics, though, are do you know what similarity means, and can you write proportions? So let's get right into it, folks. Let's not waste any time. All right, problem 3-11 piggybacks onto problem 5 that you guys did in your assignment last time. Let's go ahead and label our two triangles. So you guys actually drew this as part of your assignment, and you found lengths for all of your sides. You said that was 3, that was 4, and if you did it correctly, you would have also found that this side was 5 units long. And then you dilated it by a scale factor of 2 and came up with a new triangle, A prime, B prime, C prime, that had dimensions 6, 8, and 10. Does this look familiar to you? All right. I want to introduce a little bit of vocabulary that you've already seen before in a different context, but I want to make sure you understand what it means in this context. We're going to do this by writing a couple of sentences. This first question, I'm going to just read the key part. It says, which side of the new triangle A prime, B prime, C prime corresponds to side CB? Can you write this sentence down for me? And leave a little space underneath it because we're going to end up writing 2 in here. CB corresponds to. And then see if you can tell me which side corresponds to CB. Now, corresponding, we've seen that before with angles, right? Do you guys remember what corresponding angles look like? Please say yes. That's going to be on our test on Friday. Corresponding angles, just to remind you, if I had 2 lines in a transversal, and I said, find the corresponding angle for this angle in my other intersection, could you find it? You just kind of slide it down, yeah. It's kind of like the matching part of its intersection, right? This one's on the left side here, or right side here. This one's on the right side here. Okay, so corresponding, really, it just means sort of the matching part of something else. So if I'm talking about my new triangle versus my old triangle, side CB is this side in my old triangle. What is the corresponding side in my new triangle? C prime, B prime, right? Could you write me a similar sentence that talks about the corresponding side for AB? AB corresponds to what side? A prime, B prime. Or I like how you said AB prime because we don't really need an A prime because it's at the same spot, right? Yeah. So AB prime or A prime, B prime, however you wanted to do that. Yeah, they correspond to each other. They match. They match. One of them's the one of them's the horizontal side of the original, one of them's the horizontal side of the new one. Okay. What's the relationship of corresponding sides? If I know that AC is 3, what do I do to 3 to turn it into A prime C prime, which was 6 units long? What did we do? We double it. We did times 2. I want to skip part C for right now and move to part D. Now in part D, they're asking us if we could do something other than doubling. I'm going to write down the 3 sides for my original triangle. And then I'm going to write the corresponding values for the new triangle. And the question's asking us is it possible for us to, instead of multiplying by 2, for us to add some number to each of those sides to get the new side? It's got to be the same number for all 3, yeah. Is that possible? What number would I add to each of these? Well, we said times 2, but they're asking us, can we get it by adding the same amount? It's got to be the same for all of them. 3 plus 3 is 6. 4 plus 3 is no. 5 plus 3, no. 3 doesn't work. So it's not possible, okay? Now, it seems kind of silly that they would ask this, but there's a very good reason. And that is one of the more common mistakes that people make when we start off with similar figures. They're like, oh, this one's 3 more than this one, so I should just be able to add another 3 up here. It doesn't seem like you would be tempted to make that mistake now, but trust me, we're going to see some problems where you will. So just keep in mind that when it comes to similar figures, we can't just add the same amount each time. All right, moving on to part D. Monica dilated the original triangle ABC. She got a different one than the one we did, okay? We don't have a picture of hers, but what we know about hers is that A double prime, B double prime is 20 units long. So what was her factor? What did she dilate by? How did you know 4? What's the corresponding side for A double prime, D double prime from my original? AB, and my original AB was how long? It was originally 5. So if I started at 5 and I ended at 20, we said we're not going to add the same thing. We're going to multiply. We're multiplying times 4. So her is 4 times as big. So without seeing her triangle, would you be able to tell me how long her A or B double prime, C double prime is? Could you do that? In order to do that, you would need to know what her BC was. Well, we all started with the same BC. Our BC was 4, right? So what are we going to do to that 4 to come up with our new? Not square it. I'm going to multiply it by the scale factor, which is 4. Now, squaring it would have worked for that, but squaring wouldn't have worked for this one, would it? Okay. So it's not adding, it's not squaring, we're multiplying by something. So B double prime, C double prime would be 16. Okay, all right. Hello. No, it was right at the end of class. I put in the email where he was headed. I can't remember though. Yeah. Yeah, it was like last 2 minutes of 7th period. I was in English class, I can't remember, but it's in the email. Okay, look at these 2 pictures, and let's go ahead and do. Remember, our first learning target was we want to be able to define what similar figures are. So I want you to write this down over here. Leave a little space underneath it. Similar, and I want to compare and contrast similar to congruent. We haven't gotten in super depth with congruence yet. We're actually going to spend an entire unit on congruence. That's going to come up later on in the year, on congruent triangles especially. Um, but we've talked a little bit about there's two things that must be true for congruence. And this kind of relates to rigid transformations. Because if we can go from one figure to another through rigid transformations, that means that they are congruent. Do you remember the two things that had to remain the same in a rigid transformation? Yeah, congruent figures are the same size and the same shape. And when you say angles, you're right. Angles would correspond to shape. If something has the same angles, then it's going to be the same shape as something else. So same size and same shape. Now similar figures, like these two doggies, these are similar figures, but obviously they're not the same size. Are they the same shape? And that's kind of the key thing for similarity. So with similarity, we have the same shape, but different sizes. So two similar figures are always going to be exactly the same shape with the same angles, but their sizes will be different. And the sizes are related by this thing called a scale factor or a zoom factor. I prefer scale factor. That's what I've been calling it for most of my life. Our book sometimes uses zoom factor. Can you look at these two doggies and tell me what the scale factor is? The scale factor is 3. How'd you find that? Because 5 times 3 is 15. So to go from here to here, we would do times 3. So if I told you that doggie's ear, the original doggie's ear was let's say it was 3 inches long, how long is this doggie's ear going to be? It would be 9 inches long, right? If I told you that this doggie's tongue was 2 inches long, how long is this doggie's tongue? 6 inches long. We just take the original and we multiply it by 3, right? And that's that scale factor. All right, so let's practice a little bit with this. So Casey is a pirate. You guys have probably heard this before, maybe even from me. You guys know a pirate's favorite letter? R. You'd think R, but it's not. What is it that they actually love? It's actually the C they love. All right, that's why Casey's a pirate, right? Because her favorite letter is C, or maybe it's because her name's Casey. I don't know. At any rate, she's trying to make this poster with a big letter C on it. And this is kind of her scale drawing. And her original scale drawing, let's assume each of these little boxes is 1 inch. How wide is her base of her C? How many inches wide is that? We're counting 6 inches. And then how tall? 6 by 8 inches. If Casey decided to dilate her poster by a factor of 3, how wide and how tall would it be then? So we just need to multiply both of those things by 3. So times 3 and times 3. 18 by 24. That's 1.5 feet wide. That's 2 feet tall. That's getting kind of to poster size. See if you can find me the dimensions of Casey's poster if she dilated by a scale factor of 2 and 1 and 12. And you know what? This isn't on here, but I think we should practice this since it came up in our last lesson. Why don't we do part E and do by a scale factor of 1/2? Probably be good to have something shrinking too, right? We can handle it. Scale factor of 1 is kind of boring, isn't it? Ah, tricky. See what I did there? What? 6 inches by 8 inches. If I dilate by a scale factor of 12, isn't that 6 foot by 8 foot? What's 6 inches times 12? 6 feet. 1 inch times 12 is 1 foot, right? So 6 inches times 12 would be 6. You're right. It is 72. 72 inches by 90. Is it 96? Yeah. But 96 inches is 8 feet. I just got lazy. I was like, hey, if we're going by 12, we're just changing inches into feet, right? Yeah. All right. And then half, that would be 3 inches by 4 inches. And I feel like we got this. Does anybody have any questions on 13? The next question on the next page is kind of the key thing for this lesson. So, but I want to answer any questions we have on this page. This is the setup. You guys ready for the punchline? Let's do this. Okay, now, this is kind of the key piece. We are going to be writing ratios, and ratios are fractions. Well, there's other ways to write ratios other than fractions, but we're going to be writing fractions, okay? Here's Casey with her C again. Casey the pirate. Arr. Loves me C's. Casey is going to write some ratios, and she is going to, ratios are fractions, okay? So let's start. I'm going to ask you to give me 2 fraction bars. Leave a little bit of space in between them, because we might have to do a little work in between them. And I'm going a little bit off script here. We are going to write a ratio using corresponding parts in each of our fractions. So I'm going to write one ratio that's got an 8 and a 24 in it. I'm going to write another one that's got a 6 and an 18 in it, because those are the corresponding parts, right? The 8 and the 24 are both the heights of my 2 different shapes. They match on 2 different shapes. And then the 8 and the 16 would match up with each other on my 2 different shapes, right? Corresponding kind of means matching. Now, hear this, okay? Don't miss this. It does not matter when I write my 8 and my 24 in this fraction. It does not matter which one I put in the top and which one I put in the bottom. It does not matter. Now, if you look on the page here, they put the 24 on the top and the 8 in the bottom. But if you did it the other way around, it would also be correct. Can you guys make sure you're paying attention to this and not having side conversations, okay? So to be a little different from how the book did it, I'm going to stick my 8 in the top and my 24 in the bottom. Now, if you would like to put your 24 in the top and the 8 in the bottom, that's fine with me, because it's not wrong. However you decide to do that first fraction, your second fraction must be set up in a consistent manner. You have to be consistent with these. This consistency is the name of the game. So I chose to put these 2 into a fraction because they corresponded. I've chosen to put these 2 into a fraction because they correspond. But the order that I put them in needs to be consistent. So which should I put on the top, the 6 or the 18? The 6 or the 18. Now notice I put the smaller one on the top here, so I'm going to choose the smaller one for the top here. So I'm going to go with the 6 and the 18. My question for you is, are those 2 ratios equal to each other? Yes or no? Yes, they are. Go ahead and simplify those 2 ratios for me, please. You guys know how to simplify fractions, yes? If you got a calculator that'll do it for you, go ahead and use it, but I think we should be able to do this without our calculator. And we should be able to do it relatively quickly. I'm hoping you came up with either 1/3 or 3/1, depending. Some of you may have chosen to put the bigger number on top, and if you did, that's fine. Your fraction would be flipped then, so you'd have 3/1. I'm getting 1/3, and I'm getting it for both of them. Is that what you guys got? Did you get either 1/3 or 3/1? And it was consistently both the same, right? We would not want to get 3/1 here and 1/3 here. That would be bad. All right, so these 2 ratios are equal to each other. So off to the side here, I'm going to write 8/24 equals 6/18. And I'm going to put a box around that because that's important. That is a proportion. A proportion consists of 2 fractions with an equal sign between them. And those 2 fractions have to be equal to one another. All right, they also need to be based, if we're doing similar figures, they need to be based off of consistency. Now, I'm going to write down what Casey's brother did down in this spot here. He wrote 8 over 6 equals 24 over 18. And I'm going to ask you, was Casey's brother being consistent? Was he being consistent when he wrote this down? Now, it doesn't have to be consistent in the same way that we were. He just needs to be consistent. So Casey chose to match the 8 with the 6. Okay, and then he matched the 24 with the 18. Now, did he do that in a consistent way? He did the height on the top and the width on the bottom for one shape. And then for the other shape, he did the height on the top and the width on the bottom for that one. And are these two ratios equal to each other? What is 8 divided by 6? If you put that in your calculator, what do you get when you do 8 divided by 6? 1.3 repeating, and 14 or 24 divided by 18 is 1.3 repeating also. This is also a viable proportion. Casey was also being consistent. It turns out, so one of the cool things about proportions is that there's no one way to write them. The only rule is that we're being consistent. If these both come from the same shape, then these both need to come from the same shape. And then look at the top and the bottom. If the top and the bottom were both the bigger side, then, I'm sorry, if the tops were both the bigger side, then the bottom should be both the smaller side. We need to be consistent within our fractions, and then the top needs to be consistent with the top, bottom needs to be consistent with the bottom. So my challenge to you is to write me a proportion for this situation. And we're going to see how many different proportions we can get. I'm going to see if we can get at least 3. I bet we will, because we have some creative minds in this class. Now, some of us may throw out a proportion today that is not consistent, and if that's the case, then we will fix it together. It's okay. It's okay. This is the first time we've done this. I will tell you that this is the part that's kind of the trickiest of similarity, and remember, we are going to be practicing this throughout the next 3 lessons. I just want you to write me one proportion. You're going to write me one equation that's got a fraction in both sides. You need to use an 8 and a 20 and an x and a 6. In some way that's consistent both horizontally and vertically. So I'm going to ask for a proportion. I'm going to write it down. I have my correction tape handy and ready just in case we need to fix something. I am looking for... Actually, you know what I'd love to see is at least one that works and at least one that doesn't. Maybe 2 that work and 1 that doesn't. So I'm hopeful that some of you will be bold and tell me what you wrote down. And I'm kind of hoping that somebody makes a mistake, right? Because I don't hope for that on test day, but this is the first day we're learning this stuff, and we can learn from mistakes, right? So is anybody going to be bold and you can't go wrong at this point because I'm looking for one right one and one wrong one. You're going to give me one or the other. All right? Help me out here. Help me out. There are like 8 different right answers and just as many wrong answers too. So thank you for being bold. What do you got? No, hang on.
8 over 20 equals 6 over x.
8 over 20 and 6 over x. Okay, let me check and see if we're being consistent here. So 8 and 20, what do these have in common? 8 and 20 are both the heights. Okay, so that means that 6 and x must both be the widths, are they? They are. So you were consistent. You gave me height over height and width over width. That's consistent going up and down. Now look sideways. 8 and 6, what's the relationship between 8 and 6? They come from the same shape. 8 and 6 came from the same shape. Did 20 and x also come from the same shape? Yes, so we've checked it both ways. So it's consistent, and these are both heights, these are both widths, and then going sideways, it's from the same shape, This totally works. That's a correct one. All right, next. And then Taylor, I got you next.
6 over 8.
6 over 8.
15 over, x over 20.
X over 20. You're getting ahead of us. You already know what x is, but that's all right. 6 over 8 and x over 20. So let me check and see if this works. What's the relationship between 6 and 8? They came from the same shape. Did the 20 and x also come from the same shape? Yes, they did. Okay, so we're consistent, same shape, same shape. Now let's look across. So the 6 and the x are across from each other. Those both represent the same side of the two different shapes, the bottom and the bottom. And the 8 and the 20 were the side and the side. So you were consistent both vertically and horizontally. This is also viable. Anybody want to give me a third one, Talon? Was that the same one you had? You just had them both flipped over? Okay, which would basically be the same thing. We can be certain that that's going to be correct. Do you got the same thing? Does anybody have anything different? All right. Can somebody give me one that would be wrong, that would be inconsistent somehow?
8 and x.
What do we got? Thank you. 6 and 20, I like it. 8 and x. So you said 6 and 20. What do those things have in common? I'd say don't have anything in common. They don't. 6 and 20 aren't even, they're not from the same shape and they're not the same side. And what do 8 and x have in common? Nothing. Nothing. This is a great example. A great non-example. Okay, excellent. Anybody have any other non-examples? I like that. What if I did this? 8 and 6. Can you tell me how to mess this up over here? Help me break this thing. It's got to be a 20 and an x, but if I'm trying to get it wrong, you're putting the x on the top and the 20 on the bottom, and this is going to be wrong, right? Because these came from the same shape, these came from the same shape. Do 8 and x match up? Are they the same type of, no, that's a height and that's a base. So this is no good either. Do you see how these are inconsistent? All right, so it's really easy to make that mistake. Let's go ahead now and solve. It sounds like most of you are in one of these camps. Whichever camp you are in, we're going to cross multiply. All right, whichever camp you are in, you should have an 8 across from an x, do you? What is 8 times x? That's 8x, isn't it? Write down 8x and equals. And whichever one you did, you should have had a 6 across from a 20. 8 times x equals 6 times 20. 6 times 20 is 120. One quick step of algebra will solve that for us. Divide on both sides by 8 and we'll have what x is. Some of you had already figured that out. 120 divided by 8 is 15. And that would be the solution for this version or this version. However, if you did this version over here, you would get a different answer. Okay, you guys did awesome today. Let's look back at our learning targets. Shh, guys, this is a key part of our lesson. Don't miss it. Don't miss it. Don't start talking now. Our learning target for today, can you define similarity? What is the key part of similarity? Things that are similar must have the same shape. Okay. And then do you feel confident that you can write me a proportion at this point? That you can match up matching pieces, and then check that you're being consistent on the top and bottom? We'll get lots more practice with that. If you're not quite there yet, that's okay. Thank you guys for your attention. We got a good chunk of time to start the assignment. I'm going to pass that out to you now. It is the practice test, and that's what's due on